I'm Team 9364C. I'm a rising senior, so I'll be competing next year.
I'm Cooper. I competed 8 years on Bang Rang and said it last year. Yeah.
I'm Peter. I'm from A926W, the Wigglebots. I'll be competing next year as well.
Okay, so I think we'll talk about the steps in kind of which we started with the robot. We started first with our base. We decided to go with a faster ratio. This is a 450. So we decided to go with a 3-hole gap, and let Cooper talk about that.
Yeah, so drive, we went 450 on 325s with sleds, and Parker made these bow sleds here. The idea for this bot was to be able to go over the bar very fast, but also be short enough to D-score under the goal, which it did. But learning through matches, which you'll probably see earlier or later, we realized that D-scoring is really not that viable because no one likes to double zone when they know you can D-score really well. So it's not really that important. We also thought, if you guys want to talk about the wedges and stuff.
Yeah, so we knew we wanted to be able to, actually we can demonstrate. We knew we wanted to be able to max score and max D-score, so we created these wedges in the front that actuated from the sides. This is just poly bent, but we can, if there's a long line or a big clump of tri-balls, this is a flat, non-concave surface, so we can just plow them in. However, this is also effective if we are the other player, or on the other side. We can simply drive into the barrier and push them all off at the same time. Now, this was a really good concept and idea. However, it requires a lot of driver control. It's easy to fat thumb these panels, and they can sometimes get jammed when you're trying to go up and over.
Yeah, so
Okay. And as well as our blocker, we realized that match loads were going to be pretty viable for pretty much everyone. So we decided to try to counteract that with our own blocker, which has one pneumatic piston that's single acting currently and just banded. It's banded down on this side, and then it's also banded to go up right here, just as like a sort of a band assist. Which this worked pretty well. It was just hard to get into position to and then you'd have to be sitting there waiting for them to either shoot or go away with the blocker.
Now, say we were on the scoring side. We had this puncher mechanism we built prototypes of, and then we went with this final version. We ended up not doing an intake, as you'll find out in the video recaps. We decided to go with a 2-motor puncher as a result. Now, this gave us incredibly fast punching, or incredibly fast match loading. So we have to run this at 8% speed. And as you can see, it was very powerful. However, it requires quite some strategy in having to place them in quickly and on time. We also had on the back this ratchet that would lock into this powered gear and relieve stress on the motors.
Talk about the system. Harder.
Yeah. So with the puncher, as you can notice, it's pretty fast. That's because we have a double slip gear. It's tucked away deep in here. We have 2 slip gears, right? And two blank sections, right? So rather than having just one section of teeth that interact with it, we have two, so it has faster reload times. And then on top of that, we have resetting code using this limit switch. So every time that the piston draws back, or the puncher draws back, it hits this limit switch and stops the puncher from moving, which kind of allows for a little more control, like say someone's playing defense on us.
And then, do you want to talk more about the sides? For our sides, as Parker said earlier, we used them to clear large groups of them out, which didn't prove very effective because most things were just like tucked away, or most tri-balls were just tucked away against the sides in matches.
And corners.
And corners, yes. But generally the idea was just have a simple pneumatic that pushes it in, pulls it out, double acting. And then we'd have polycarb and then a small wedge to get them over the barrier as well.
Now, as you can see, we have this one button that we made later in the match that just deactuates everything. But we were able to fit under the goal completely. This allowed us to kind of like, I don't know, de-score better than, well, we were the only team that could de-score. That kind of gave us an upper hand, but like we said, no one was really de-scoring, and it wasn't that big of an advantage, and that you could really only de-score a few at a time. It was really hard, because we would always go through this side and try and sweep them that way. You can't really fit in and push them out that way, which kind of made it, this bar is obviously tougher to get the tri-balls to do than the other, right? So
The other team knows we build our bot to be able to de-score really fast. So, their strategy automatically goes to not double zoning, so that we can't use our strength at all. So, although this being able to fit under the goal is like, it really is like good and helpful. It's not worth it because the other team doesn't have to do anything, and you can't use your strat. So we had these walls to just push acorns over to the other side and score them, but we realized that intakes are like definitely the way to go. If we were gonna do it again, we'd take these two motors in the back here and ratchet one of them to an intake in the front. And we wouldn't really worry about making this 5.5 inches tall. We probably, we would definitely have the blocker for sure. Maybe these, but they weren't really that useful. But definitely an intake and a hanging mech. One thing we were going to do, but we ran out of time, was we were going to use our blocker for a hanging mech. And what we're going to do was, which we had space for, we're going to make a 1 bar or a 4 bar with a roller that's passively mounted and cocked forward with a roller here. And so this can freely go up and down throughout the match, but at the very end, it would be a pin pull piston assist hanging thing, and it would be rubber banded back, and there would be hooks on this thing, and it would just curl the robot up onto the horizontal portion, which would have been really good and fast. We just didn't have enough time because it was an RI3D. And yeah, that's kind of.
And then we're gonna talk about the hard stop.
Yeah.
So for our hard stop, as you can see, we have bands from wrapped around the puncher all the way to a standoff over here. And then we have a rubber stopper on the puncher to hit the ball, or the tri-ball, as well as a rubber stopper right there to lessen the impact. And then we have all of this boxed and 2 screws down because we had a problem when we were testing where we had 1 screw and then it bent. So we had to remake that, and it worked pretty well. But as Cooper said, it was flawed by design with a 5-inch thing.
One thing I did forget, when we were attempting to build our drive, we noticed that because we were using 3.25-inch wheels, they would sink like into the bar really far, and so it would jumble over the bar, and it was like a waste of power and material, like efficiency. So we put this C channel here with cuts, and so what it does is when the first wheel, it just props it up really easily, it just goes over, and this is kind of a sled between this wheel and this wheel, and so it just kind of guides it over, super smooth, and then our back poly flexes out of the way, and we can get over very easily. If we were gonna do this again, we'd probably make this hinged and mechanical stop back here, banded probably, like bends, and
then another thing, or the way we made it flexible, so we just didn't tighten these screws fully, which somehow worked very well. And another thing, if you were to do something similar to this, you don't really need the poly to be that long, because you can see the tri-ball contacts around here on the mass extinction sticker. So you could cut off about maybe a ½ inch or more, and because our poly was so long, it caused a little bit of a problem when we went over the barrier. Even though we could flex, we would still like scrape the ground at one point and get stuck.
This robot was like, it was a really good design, and it definitely would be very competitive. However, we kind of went into it, and we kind of did finish like a little last moment. We didn't have time for a hanging mech, and we had no driver practice, barely an auton. With some really good driver practice and some good strategy, this could be a very competitive design.
Robot in 3 days.
it's a robot in 3 days.